Next, myself A. Ramanjanayalu. Next, I am going to explain about section modulus. Okay, section modulus, it is defined as the ratio of moment of inertia of a section about the neutral axis to the distance of the outermost layer from the neutral axis. It is denoted by Z. The section modulus is denoted by Z. It is the ratio of moment of inertia I to the distance of neutral axis to the topmost layer or bottommost layer of the beam is known as section modulus. The I is denoted by moment of inertia about neutral axis. Next, Y max is equals to distance of the outermost layer from the neutral axis is known as section modulus. From bending equation we know that M by I is equals to sigma by Y. Here in this problem, in this condition, the stress sigma will be maximum when Y max observed. Here Y max, that is stress is increased means, distance from neutral axis to the topmost layer is increased means stress also increased. Okay, that means Y is maximum, the stress is maximum. Hence, from the above equation we can written as M by I equals to sigma max by Y max. If Y value decrease means the stress value also decrease. Okay, so that if the stress in the bending stress is depend on the Y value, M is equals to sigma max into I by Y max. That means I is come to right hand side, it will go to denominator, so that sigma max into I by Y max. I by Y max, we know that I by Y max is known as Z. Okay, in place of this equation, M is equals to sigma max into Z. In the above equation, M is known as bending moment or moment of maximum bending moment or moment of resistance is known as section modulus. Okay, now we will go to discuss section modulus for different sections. Here, section modulus for various beam sections, it is the rectangular section. Okay, that we need to calculate the section modulus for rectangular section. It is the rectangular section having width B and depth D. Okay, distance from neutral axis to the topmost layer is half of the thickness, that means D by 2. That is moment of inertia of a rectangular section about neutral axis is known as I is equals I by Y. So that we need to calculate I value and Y max value. For every section, the moment of inertia and distance from neutral axis to the topmost layer will change for every section, so that we need to calculate I and Y value for every section, so that I is equals to formula for moment of inertia for rectangular section is BD cube by 12 and Y max is equals to D by 2. So that means half of the total thickness, so that total thickness is D, so that distance from neutral axis to the topmost layer is half of the depth, so that it can be written as D by 2. Next, coming to section modulus, we know that formula for section modulus Z is equals to I by Y max. Substitute I value and Z value in this equation. I is equals to BD cube by 12 and Y max equals to D by 2. By simplifying this above equation, we will get the value is BD square by 6. It is the section modulus. Z equals to BD square by 6. It is the section modulus for rectangular section. Okay, in similar way, we need to calculate section modulus for hollow rectangular section. Okay, now consider a hollow rectangular section. It is the B, capital B. It is the overall thickness, outer breadth of rectangular section, and small b is the outer width of the rectangular section, and capital D is equals to outside depth or thickness of the rectangular section, and small d is equals to inside or inner thickness or depth of the rectangular section. Next, distance from neutral axis to the topmost layer or outermost layer is known as half of the distance, is known as capital D by 2. Okay, for hollow rectangular section, moment of inertia is capital BD cube by 12 minus small bd cube by 12. By simplifying, we will get 1 by 12 as common. The remaining equation is capital BD cube minus small bd cube. Okay, and Y max is equals to capital D by 2. Okay, substitute these values in section modulus equation. That is, we know that equation, that is I by y max. I is equals to 1 by 12 into bd cube minus small bd cube by 12 by y max is d by 2. By simplifying this equation, we get the formula for section modulus for hollow rectangular section is 1 by 6d into capital BD cube minus small bd cube. Okay, it is the section modulus for hollow rectangular section. Next, section modulus for circular section. It is the formula for I is equals to pi by 64 d power 4. It is the moment of inertia for circular section. It is the circular section having depth d and diameter d, and distance from neutral axis to the topmost layer is d by 2. Okay, z equals to I by y max. I is pi by 64 d power 4 by distance from neutral axis to this point is d by 2. So that the formula for section modulus for a circular section, that is pi by 32 d cube. It is the formula for section modulus for a circular section. Similarly, hollow circular section. Consider a circular section with hollow inside having inside and outside diameter. Okay, outside diameter is capital D and inside diameter is small d. Distance from neutral axis to the topmost layer is capital D by 2, and formula for moment of inertia for hollow circular section is pi by 64 d power 4 minus small d power 4, and distance from neutral axis to the topmost layer is capital D by 2. Okay, we know that formula z is equals to I by y max. Okay, by simplifying, by substituting this I value and y max value in this equation, we will get pi by 64 capital D power 4 minus small d power 4 by d by 2. Okay, by simplifying this equation, we will get the section modulus value is pi by 32 d power 4 minus small d power 4. It is the value of section modulus, formula for section modulus for hollow circular section. Okay, it is about section modulus. In next class, we will discuss the problems regarding the bending equation and symmetrical and unsymmetrical sections. Okay, thanks for watching.